Hello and good morning. Welcome to the Royal Academy of Engineering's Education and Skills Policy Seminar series. Lots of people asking, when is it going to start? So you're all very keen this morning. I'm Rhys Morgan. I'm Director of Education at the Academy. Last week, we had a really great talk from Paul Shakespeare of the UK High Value Manufacturing Catapult on the development of the new skills value chain that they have developed for emerging technologies. Well worth a watch if you didn't see it already, and you can find it on the Academy's website under the education section, along with all the other seminars that we've had so far. Now, just also to remind you that today's seminar presentation will be recorded. I can just about remember those Monday mornings, Tuesday afternoons, Thursdays, and come to think of it, Fridays as well, when we spent endless hours in lecture theatres writing out seemingly endless pages of derivations of engineering equations. And much has changed in the last 20 or so years. Long gone of the thoughts of possibly being able to do some kind of practical work without the workshop technicians getting grumpy with you. Since then, there have been kind of huge shifts in engineering education, and things like big high-profile project-based learning approaches like CDIO and wholesale changes in engineering education like that's come out of Olin College in the US, have really kind of ripped up the rule book in terms of how we teach engineering education. The UK is about to see two new universities taking very radical and different approaches to delivering engineering education. They are Enmite in Hereford and TEDI, a new collaboration between King's College London, the University of New South Wales and Arizona State University in East London. But what's going on in the rest of the world? Well, to answer that question, we have one of, if not the most knowledgeable person on the planet in terms of engineering education, Dr. Ruth Graham. She has a contact book to die for in engineering education. If you want to know who the leader is in Australia or Chile or Malaysia or Denmark or the Netherlands, she's the person to go to. She's a mechanical engineer by background, working in the aerospace sector. She then moved into engineering education in 2002 at Imperial College London. Little known fact, she was appointed by Professor John Perkins. Is there anyone the man hasn't appointed in engineering education? I don't think so. Ruth has worked since 2008 as an independent consultant on transformation in engineering education. The Academy's worked with her lots of times, and she's worked with many, many organizations all over the world. The presentation today is based on her 2018 report for MIT on the state of the art in global engineering education. Just a quick reminder that we will be having a Q&A session at the end of the talk, so please do post your questions in the Q&A box at the bottom of your screens. And without further ado, that's enough from me. I will now hand over to Ruth. Thank you.
Thank you. Thank you for that kind introduction, Rhys, and it's a pleasure to be here. I'm talking today about the changing face of engineering education. It's a really interesting time, as Rhys said, to be looking at and talking about engineering education. We really are at a tipping point, and entering a period of quite rapid change in engineering education across the world. After 3 or 4 decades of talking about the need for change in engineering education, the need to nurture graduates with the capabilities to solve the complex multidisciplinary challenges facing the world in the 21st century, we're really seeing some quite interesting and rapid change. So just to set a context, the next slide, please. Engineering education has been, for the last half century, a relatively traditional discipline, following a teacher-centered sage on the stage pedagogy. The curriculum in many institutions had remained largely unchanged for 50 or 60 years, focused on the engineering fundamentals, the maths and the science, delivered through lectures, through problem sheets, through labs, with perhaps some a small number of projects, group projects or single projects for students. But actually, in many ways, many other ways, the education really had changed very little. And that was certainly the education that I had, obviously, that Ruth had nearly 30 years ago when I studied as an undergraduate in engineering. On the next slide, one of the things that was released actually while I was an undergraduate was Boeing released their 10 capabilities that they desired, or 10 attributes they desired of an engineering graduate. I was really interested when this came out because I was an undergraduate who wanted to go into aerospace and did go into aerospace. And I think what's particularly interesting about this list is the first two. So the good understanding of the engineering science fundamentals and the understanding of design and manufacturing processes are something that really is that has been the key focus of engineering education, delivering that kind of maths and science and those fundamental understandings. But the other 8 aspects that Boeing was calling for more than 25 years ago very often haven't been touched upon in engineering programs. The multidisciplinary perspective, the understanding of the context of engineering, communication skills, ethical standards, critical thinking, flexibility, curiosity, and understanding of teamwork. They very often were confined to single experiences, to, let's say, one particular course of a project that students were solving, but actually really weren't learning outcomes across the curriculum as a whole. And this is something that really has changed and is changing quite fundamentally. And this is what I want to talk about in the talk today. So on the next slide, the 3 questions that I will be looking at are, firstly, why now? We've been talking about this for a long time. We're talking about the need for change. Why is it happening now? Why are we seeing these things happening, particularly in the last 5 years, and building up for a momentum for greater change in the future? Secondly, which are the institutions that are really global leaders in the field? Which institutions are people across the world looking to for inspiration, and what are they doing? And finally, what are the likely future directions for the sector? So looking at the first of these questions, why now? Why is this happening now? So on the next slide, I think I would say there are 4 reasons that I would identify as to why change is happening now. First, simply as people are getting more vocal about the need for change, industry, professional bodies, and including the Royal Academy of Engineering in that, and students are becoming more vocal about the need to rethink the way we design and deliver engineering education. And the next slide. The second is around evidence of the impact of new pedagogies on student learning. And I think one of the things that often held academics back and engineering schools back from fundamental change was this sense of a zero-sum game. We don't want to dilute the engineering fundamentals by bringing in other things, by helping the students to develop their mindsets and their skills. A sense that if you bring in other dimensions, that you're going to dilute the science fundamentals. And there's been some really interesting research evidence that's come out over the last 15 years or so that demonstrates that it is possible to, with a carefully designed curriculum, to actually have a blend of both. So I'll just give you one example here that I think has been quite influential from Denmark in the next slide. It was looking at comparing the outcomes really from 2 different types of education. So 125 Danish firms were surveyed to compare the competency of engineering graduates from 2 different universities. One, Aalborg University, where the education was delivered in a problem-based way, and the Technical University of Denmark, DTU, where at the time it was very much more traditional lecture-based education. And the firms were asked to rate the competencies of graduates from these 2 institutions in various dimensions. So on the next slide, you can see that these are the competencies that they rated for the DTU graduates. They rated them very highly for their technical understanding of the engineering science, but for the other aspects, much less so. So knowledge of business life and economy, people and project management, they assigned much lower scores to those graduate attributes for the graduates from DTU. But on the next slide, you can see these are the attributes that they assigned to the graduates from Aalborg University. And I should say that the intake for both universities is very similar in terms of profile and cohort size. They assigned for the graduates of that institution much higher scores against the personal and professional skills and mindsets, innovation, creativity, contact and working relations to industry. But crucially, they also attributed the same level of competency to the technical side. And I think it's this kind of evidence that has convinced many academics and engineering schools that it's not such a risk to make a change. In the next slide, I think the third reason is, and I think this has been incredibly important, particularly in recent years, is governments across the world are calling for investment in the technology innovation pipeline and looking to engineering schools as the incubator for that talent that will be the basis for this technology innovation that will drive economic growth. And in the next slide, I think a really interesting example of that is in Chile. And this is something that I've looked at in a separate study looking at educational change in engineering across Chile. In 2014, the Chilean Finance Ministry invested $200 million in engineering schools to develop this technology innovation pipeline. It's interesting that it's the Ministry of Finance, not the Ministry of Education. So this is really about looking at the economy and economic growth. But in particular schools in Chile, there's been a phenomenal change from what was a very long and traditional education to something that's much more hands-on, innovative, really a strong focus on entrepreneurship and innovation, working with local industry, with startups, and students really moving outside of the borders of the campus. And that's been an incredibly marked shift in Chile. And finally, in the next slide, I think simply why are these changes happening now is competition, that more and more institutions are making fundamental changes to their education, teaching very differently than they have in the past. And I think it changes the status quo. When you have institutions like UCL in the UK or MIT in the US making fundamental changes to their engineering programs, that sends ripples across the sector. So for next slide, the next question that I looked at and wanted to look at is who are these leaders in engineering education? What does the global state of the art look like? And what are these institutions doing? In the next slide, I was commissioned, as Reese mentioned, by MIT to conduct a review of the global state of the art in engineering education, in part to inform their new reform, which is called NEET, of the undergraduate curriculum, which has now been rolled out. And actually, the first cohort graduated just last week from that 3-year program. And the study itself looked at global best practice. I consulted almost 200 individuals, practitioners, innovators from across the world in engineering education. Included in that was a group of 50 thought leaders from 18 countries across the world in engineering education, asking them a series of questions about where they considered best practice to be, but also where they considered the sector to go, and what are the challenges that constrain change and improvement in engineering education. One of the questions I asked all of them was, which universities do you consider to represent the current leaders in engineering education? I asked each to identify five programs that they considered to be current best practice. Pulling all those recommendations together, in the next slide, this shows the 10 institutions most frequently identified as current leaders by this group of thought leaders. I think some very familiar names there, I think, in terms of the global rankings in engineering. Probably the less familiar institution is the one that Reese mentioned, Olin College in the US, which is a new institution just set up 25 years ago. The next question I asked is, okay, so these are the current leaders. Who are the emerging leaders? Which are the institutions that you would consider to represent the future of engineering education, that will represent the cutting edge in the next 10 years? And the next slide shows the institutions that they identified as these group of emerging leaders. And what struck me immediately when I looked at the most frequently identified institutions was there were some less familiar names in that group. such as Iron Range Engineering, SUTD, Charles Sturt University in Australia, that there's a broader range of different institutions. And one of the interesting things that I did when I saw these two groups of institutions, the current leaders and the emerging leaders, was to think about what's the profile of each and what are the distinctive features between these two groups of institutions. And I'll just give you a little flavour in the next slide of some of these differences that I thought were really interesting. So amongst the current leaders, there was what we would call a traditional gender balance in engineering, depending on subject, but maybe 15 to 20% women. For those institutions, the curriculum was still structured in a more traditional way, structured around the engineering knowledge, around lectures, very much a teacher-centered approach with more limited external connectivity. And the good practice that people were identifying were tended to be constrained to particular pockets of practice, taught often in isolation within the courses. In contrast, looking at the emerging leaders, many of those institutions had much higher proportions of women, in some cases gender parity, which is very unusual in engineering. An emphasis on a much broader range of skills, knowledge, skills and attitudes, building on the engineering fundamentals, but really looking at these broader learning outcomes across the curriculum as a whole, rather than in discrete components of the curriculum. A real culture of student empowerment and external collaboration. And this was a real culture, I think, that struck me very much. You go onto the campus and a real sense of that student empowerment. Some felt almost like a startup culture, and a very strong sense of collaborating outside of the institution with the local community, with industry and with others. And a systemic and unified approach, that connectivity across the curriculum. And just to give you an example of that, on the next slide, if you look at all of the institutions identified as emerging leaders, in the next slide, you can see that of those, 7 of those institutions are either fresh starts, completely blank slate institutions shown in green, or were the result of a systemic reform to their undergraduate programs shown in red. So that's a real difference with these institutions, that this curriculum has really been designed from the ground up. And also in the next slide, there were some really distinctive features in terms of the kind of education that they were delivering. So in addition to the grounding in the scientific fundamentals, the engineering fundamentals, which was core to each of these curricula, these emerging leader institutions particularly focused on multidisciplinary learning, with a number of them not actually even having traditional siloed engineering schools, or even as an institution having departments in any traditional sense. The students having a much greater connectivity globally and having experiences outside the country and outside the institution. A strong focus on creativity, innovation and entrepreneurship. A really hands-on education, experiential learning, real-world problem solving, often underpinned by a very strong focus on user-centered design. The roles and responsibilities and ethics of engineers in society was a really strong theme coming through from many of those institutions. And finally, students' choice and flexibility, both choice and flexibility in terms of the students' education, and in some cases really being able to identify and weave their own path through the education, but also in terms of the design of the education. So you look at somewhere like Olin College, where the students themselves help to design the curriculum in the first year, but this real sense of student empowerment. So just to give you two examples of that, on the next slide is one example from UCL. So this was an institution that reformed, a root and branch reform across the School of Engineering, and launched this new integrated engineering program in 2014. I'm aware, I can just see John Mitchell's name as one of the attendees here who is led that change, who will know much more about that than I do. But it's a really interesting program. It's a common curricular structure built around engineering projects. In the first 2 years of study, they have 5-week cycles that culminate in a 1-week intensive full-time project which they call scenarios, and all of the student learning in the preceding 4 weeks feeds into that. And those scenarios are very much connected to real world projects that the students tackle in teams. A second example is on the next slide from SUTD. This is the Singapore University of Technology and Design, a completely new institution established in 2009 in collaboration with MIT. They took some of the MIT curriculum actually to start that program. This is an institution where there are no departments or schools, and the university offers a multidisciplinary education. Design and design-centered learning is immersed throughout the education, really pulling together and allowing students to contextualize their learning across different subjects, and a real breadth of education. There's a really strong focus on global experiences, internships, student research opportunities, and a lot of education in humanities. Despite the fact this is a technology and engineering institution, there's a really strong focus there on humanities as well. So the third, on the next slide, the third and final question is, what are the future directions for the sector? Where is engineering education likely to go in the future? And I would identify in particular 3 future directions that I think are particularly interesting. Obviously, we're in a time of particular change at the moment with the COVID-19 restrictions and the rapid move to online learning institutions across the world. And I think each of these really has been influenced by those restrictions, and each of these themes, even though I would have identified them more than 3 months ago, I think they are all influenced in many ways, and in some cases accelerated by the shift to online learning. So the first is the improving the reward and recognition of teaching. This is something that's bigger than engineering, but this is something, and I've worked quite a lot in this area, because the reward and recognition systems are so much seen to be barriers to innovation and excellence in teaching, where university promotion systems really rest on performance and impact in research, and teaching very often plays a much more minor role in appointments and promotion. And this is something that's really changing. In the last 5 years, it's been huge, the number of institutions engaging with fundamental change. And it's not just been institutions that are making changes to their entire career pathways, it's countries. So there's a number of countries like Malaysia, like Denmark, like Norway, that are making countrywide changes to their academic career pathways. The most significant example is the Netherlands. All 13 research-led Dutch universities got together and decided as a group to change their reward systems and create a common set of academic career pathways. And the reward and recognition of teaching will be much more central to that. That's just being designed and rolled out at the moment. But I think those sorts of changes will be incredibly impactful across the sector. The second shift and future direction likely to emerge in engineering education is a tilting of the global axis of leadership in engineering education. So in the next slide, this is a shift really from north to south and from high-income countries in the emerging economic powerhouses in Asia and South America. And I think this is a really interesting shift, and this is something that came out quite strongly from the MIT report. So when I asked these thought leaders, firstly, which institutions do you consider to be current leaders in engineering education, there were 250-ish recommendations that they made. When I plotted those by geography, by what country, what region are these universities in, on the next slide, you'll see that the vast majority are in North America and Europe. Over 80%, 83% of those are in North America and Europe. But then looking at the same number of recommendations made altogether by all 50 thought leaders of the emerging leaders in engineering education. In the next slide, you can see that there's quite a different geographic spread there, that the North American European institutions represented half of the recommendations. A third of those recommendations were based in Asia, and a significantly greater number were based in South America. And when talking to the thought leaders about these institutions and why they were recommending them, it was interesting that a lot were saying, well, it's not necessarily about current practice, but it's the trajectory and the speed of travel that's really interesting. And again, I think this is something that's going to be influenced by COVID, a sense of that shuffling of the pack, and that actually the institutions that come out of that as leaders won't necessarily be the same institutions coming in. And I should just say, in terms of the reward and recognition of teaching and the change due to COVID for that, it's the conversations I've been having with university leaders that are implementing these changes. A lot of them are saying that the shift to online learning has really brought into sharp focus the importance of high quality teaching and really thinking about the learning outcomes in delivering these remote experiences, but also the extent to which universities really are reliant on in student fees and overseas student fees, and that actually that will be played out in reward and recognition systems. So, and then the third future direction in the next slide is about scaling up good practice. So if you look at an institution like Olin College, obviously it is seen across the world as a real leader in engineering education. It's a very experiential learning environment. The students are very much supported to develop creativity, innovation, but it's a very small education. They only have 85 students per year across the institution entering the university. That's a very small cohort. The question I think many in the engineering education community are asking is, okay, so how do we provide that kind of quality of education at scale for large, diverse cohorts when we don't have the same kind of per capita spend that somewhere like Olin College would? And I think there's some really interesting thinking about how do you make this work at scale. And on the next slide, I'll just give you one example of one development that I think has been incredibly interesting, that you can see being implemented in the Tech 21 curriculum at Monterrey Tech in Mexico, and also at Charles Sturt University in Australia. And it's this idea of putting the taught curriculum all online, and putting it online in a way that students access independently, and having all of the face-to-face learning focused on experiential learning, on projects, on facilitating that breadth of student learning, and so that they can bring together their knowledge and skills and apply it to these problems. So I'll just highlight a little bit about what Charles Sturt is doing, which I think is incredibly interesting. So in the next slide, they've created what they've called a topic tree, which you can see. I know you can't see any detail of that, but they've disaggregated the entire taught curriculum, which in their case is a civil engineering curriculum, into discrete 3-hour topics, and students access those independently. The topic tree itself offers a visual map of the relationships and dependencies between each of these topics, so the students can really kind of place their knowledge and understand how this all fits into the whole. And some of those topics are core. All students have to learn them, regardless of what they're doing. But for the rest, while they're given projects, they're working on different challenges, they identify, what do I need to learn in order to solve this problem? And they identify on the topic tree what they need to learn, they master it, and they complete that portion. And they can continue to access that topic tree following graduation. Which I mean, I think this is an incredibly interesting model, and it's one that a lot of universities are looking to develop in the future. The question that a lot of universities, of course, are asking now is, okay, so how do we deliver all of this online? Not just this kind of taught curriculum, but how do we deliver high quality experiential learning when everybody is remote? The students are remote from the academics, the students are remote from one another, and actually accessing the local community, industry, all those other external partners that might have been part of these experiences. How do you make that work? How do you know that the students are learning what you want them to learn? And how do you assess that? And that's actually the next piece of work that I'll be doing. We'll be looking at that and looking at what is best practice worldwide, and what are the kind of opportunities and challenges that universities face in delivering that in practice. So just finally, in the last slide, just to conclude, Thank you. That engineering education is in a rapid period of change. The last 5 years has really seen a lot of change in many, many universities across the world, but actually that's only set to increase in the future. And these new models that are emerging are seeking to nurture not just the technical engineering fundamentals, but skills and mindsets across the curriculum. Innovation, creativity, flexibility, a whole host of mindsets as well as skills. And the influence of these approaches is becoming more and more evident in universities across the world, including in the UK. And there are also some other wider significant changes underway in terms of reward and recognition of teaching, but also in thinking about how more of the education can be delivered in a meaningful way online. So thank you very much for your time, and I look forward to hearing your questions. Thank you.
That was really fascinating, and I have to admit, when I first read the report, I was embarrassed to say I didn't know a few of those emerging universities myself. Shows we're all still learning. Apparently my broadband isn't working very well. It's probably my kids hammering Minecraft upstairs while I should be doing homework. If it gets too bad, then someone somewhere will turn off my video, so you'll just get a mugshot of me and hear my voice. I just wanted to pick up a couple of things right from the start. You mentioned early on about Chile, and this is really fascinating for me, that the state is kind of intervening in engineering education. So actually going right down into a subject area within higher education. Have you seen that elsewhere? Is that common? Is the UK an outlier in terms of, you know, how the government engages with particular branches of higher education?
I mean, I think it's increasingly common. I think Chile is interesting because they're focusing very specifically on innovation, entrepreneurship, but it is something that you're seeing in other countries across the world. What's interesting with Chile actually is that they, because of the success with this in engineering, they're now investing in science. And a similar investment is now coming through in science, but I think it's been incredibly interesting, and actually those national collaborations. So one of the requirements was that the engineering schools work together. You know, they had partners, that this wasn't just a single enterprise, but they were tackling this issue together. And I think that kind of collaboration as well has been incredibly powerful in sharing best practice and supporting each other. And, you know, a lot of these changes aren't cheap. And even if you have funding from the government, that actually developing these ideas and there are failures as well as successes, as with everything, but actually sharing those experiences and ideas and resources together, I think has also been really, really powerful. But I think the fact that the Chilean government is now investing a similar amount in science education speaks volumes for how they feel that has impacted the sector.
Yeah, it really does. Now, just a quick note. So typical engineers are breaking the system. This has been working fine all the way along for the last 5 weeks, okay? Get a load of engineering academics on and they start posting the questions in the chat box, not the Q&A box. The teachers get this fine. I don't know why the engineering academics have to break it. So please use the Q&A box, not the chat box. I can't monitor both boxes. Thank you. Just another quick question from me, and I'll go to some of the questions. Now, you looking at those universities, it was clear that a lot of the kind of advances are coming from those universities that are kind of starting out with a blank slate. And it's much easier to transform your provision from a blank slate rather than, you know, from an established setting, from an established curriculum and within an existing university structure. So kind of UCL, having done that in the kind of within the existing university requirements. I mean, what are the challenges in doing that?
Mm-hmm. There are significantly more challenges. I mean, a fresh start is still challenging in that your academics have to come from somewhere, and they've almost certainly come from somewhere where they taught differently. But you're absolutely right. I mean, it is a much bigger challenge, and there are significant barriers. I mean, a big part of it is culture and the culture change, and I think it's really engaging. If you look at the universities that have been successful, they've really engaged with the academic community on both the need for change, but also in the design, that this isn't something that's just thrust on the academics. Now you're developing this, or you're delivering this, that actually they're part of that development process. But I think there's also key barriers. Students are often bigger barriers than people expect, that they come into an education and they're not getting what previous year groups had, and they're not getting what their peers had, and there's a real worry, is this being diluted? And I think that problem of are the engineering fundamentals being diluted here, and am I not getting a proper rigorous education? So I think it's really engaging with that. And I think what a lot of universities have found actually in days of Twitter is that when students are unhappy, they go to Twitter, and they go very quickly, and actually you can very quickly see when there's a problem within an hour, of some of these new experiences. So I think really engaging with the students as to why are we doing this? What's the evidence that says this is important? And what's the evidence that says this is having a positive impact? I think the other piece, I mean, there's a few things. One is really engaging with department heads. They are absolutely critical. If they're not on board, it's extremely difficult to push through change for many reasons, not least that they're typically the people who nominate for promotion. And if people don't feel that their head of department is behind the change, they're going to be more reluctant to engage. I think it sets the culture for the entire department. So there's a lot of barriers, but the key thing really is engaging with people and listening and taking on board the concerns of the academics and the students.
Thank you. One of the things that's come up a couple of times in the questions is, of course, COVID-19. And under the so-called new normal, how are places like Olin College and others, very heavily kind of practical, hands-on based approaches, universities offering those kind of approaches, how are they going to deal with this kind of new social distancing?
I think it's extremely difficult. I mean, this has been an immediate shift, and for a lot of those institutions, a defining part of that is sort of is getting together, is projects, is working together, is experimenting, it's hands-on. Those institutions, and I think if you look at somewhere like Olin, it's perhaps easier because you have such a small cohort. You can almost talk to the students one-to-one about the projects and providing that kind of support. But I think a lot of universities are really feeling their way and looking at and it's trial and error, looking at what works. So in the NEAT program at MIT, I know that they've been asking students to work on projects based on what they have in their houses, just looking at, what have you got in your room, what can you produce from that, and actually really adapting some of the projects to the environment that students are in. I think what a lot of universities are doing are making things work for the time being. Let's just do our best, but think a little bit more strategically, or a lot more strategically, about the kind of programs that we're delivering in September. But the reason that I wanted to do this next study is I think a lot of people are thinking, I really don't know how to do this. And I think there's a real concern for a lot of people that will take a step back, or that their institution will take a step back and say, look, I know you've been doing something very innovative in your statics class, but just for the time being, why don't you just deliver it as a lecture? Because at least we know that the material is going out there, and then we'll think a little bit further down the line. So I think there's that concern that that institutions may take a step back, that they don't then reverse. So I say that's the real reason that I wanted to look at this, because a lot of people have been saying to me, where is best practice? Who are doing the interesting things here? And what can we learn from them? And that's why I wanted to look across the world and saying, what's happening and what can we learn from other institutions doing interesting things.
Really interesting. One of a number of questions, in fact, have come up on the accreditation. the dead hand of accreditation, stifling innovation. Is this true? What's happening? I mean, in UK universities, there's often this debate about professional bodies stifling innovation. The professional bodies say it's not true. I mean, this is, we have accreditation all over the world. So what have you seen in terms of how the professions are supporting innovation?
It's interesting. I think I would, even on a webinar, I would always know I'm giving a talk to a UK audience. If the question of accreditation comes up, it's a UK audience. I mean, it's clearly a bigger deal in the UK. So just come back to the example of Chile again. Actually, the universities that are really being innovative are deliberately applying for ASEE accreditation. So the US accreditation, and that they see that as a sort of badge of quality on the programs. I mean that there are issues. There are issues worldwide about accreditation and what kind of this sense that programs are kind of being compressed into a certain size and shape. I think I see this in the UK as being much more of a concern. And I think you'll have some institutions saying, actually, if you talk and engage with the accreditation bodies, they're much more flexible than you think. But I think for a lot of engineering schools, a real genuine fear: if we do this, will we be accredited, and how do we know before we go into the process? And it's not clear to me whether this is a genuine problem of the accreditation really being much too heavy-handed and not allowing institutions to have that flexibility to rethink the entire structure of their education, or whether this is a perception problem that engineering schools and departments don't know enough about what the accreditation bodies will allow and will accept. But to me, that there would be a lot of benefit in really opening that conversation up, and having much more material available. If there is that flexibility, really being explicit about what we will allow you to do, because in the UK, more than any other place, when people talk about the barriers to change, accreditation comes up consistently, and as a real genuine fear that we could really put ourselves in a very difficult position come accreditation time.
Yeah, absolutely. I think it's you're absolutely right. We do need to have that kind of the two-way communication between the professional bodies and the universities, and the academy should probably do something about that, I think. One of the other things that's come up frequently is around industry engagement, and I'm interested to know if there are different, in different countries, there are different cultures between industry and university collaboration. We sometimes find it hard to get industry to collaborate on teaching and learning in the UK, whereas of course in research they're very keen to be involved. So I'd be interested to know that. And the other thing that came up was around, we heard about this last week when we were talking about centres of innovation. So in Singapore you have the industry advanced research centres. Do they have a role in teaching and learning, or do they and do the universities collaborate with them as well, or are they kind of separate entities?
Looking first at the industry engagement, there are different approaches. So, I've worked a lot with MIT, and they have a lot of existing structures around strong engagement with industry. But actually, it's not been until they've developed this new NEAT curriculum that they've really strategically pulled those in and thought about which industries they want to be involved in each of these projects at a holistic level. One thing that is very clear is that of the universities that are really engaging with industry, it's a full-time job. That actually, when you look at the people who are working on these curricula, there's very often at least one person working full-time, exploring and securing and maintaining those relationships, and really thinking about, what's the spread of industry and startups and whoever in the external sphere that we can engage with, and how do we best use that in a way that's sustainable, and really building up those relationships. But that's something that's really struck me. So if you look at Penn State University in the US, or University of Queensland in Australia, they have full-time people, more than one full-time, working on those relationships just for engineering. And I think that's been a real key, and it's a lot of investment. There's a lot of money and support that goes into those relationships. So I think it's not as easy as it looks from the outside. And I think often you look at a program and think, wow, they've got this wonderful set of engaged partners, but there's a lot of beneath the surface. There's an awful lot of work going in to maintain that. And I think in terms of partnerships, if you look at looking at some of these institutions that are really doing interesting things, very often there's an engine there in terms of at a national level in terms of supporting, or at a region level in terms of supporting collaboration, particularly around technology innovation. And so there's perhaps it's part of this ecosystem that's supporting technology innovation, and the university has really engaged very strongly in that. But that's not always the case. So there are some universities that are really working themselves, and all of the engines for that are within the institution itself.
Right. One of the other areas of around industry collaboration is, and particularly in the UK now, is degree apprenticeships. And John Morden who posed the question, he's working with the Institute for Apprenticeships and Technical Education in the UK, in England, and he's looking at the growth of degree apprenticeships in engineering from undergraduate through to doctoral. These are driven by employer needs and are by definition workplace focused. Can you comment on how higher education providers across the world are engaging with employers in terms of their requirements and how they feed into course structure, programs, and so on?
And I think on that it's very varied. It's very varied by institution, and it's very varied by country. There are some examples of, so the Charles Sturt example from Australia that I mentioned, that's got this topic tree, that is actually a 5.5-year degree, and the first year and a half is on campus. The next 4 years is all through work-based learning. It's effectively apprenticeships. They're paid throughout that process a salary by the companies that they're working with, and each year they can opt to work in different companies. And a lot of those models are very successful, and I think for bringing in a much broader group of students. So for that particular cohort, most of those students, the alternative to studying on that degree wasn't an undergraduate program. It was working in the field elsewhere. So I think a lot of those programs have been successful. But I think there is a balance. And again, I think it comes back to this, having people full-time that are really dedicated to this, that are you simply asking industry to give us good opportunities for our students, or are you working with industry to really fill their needs and to look at their priorities and actually have a match between what's good for the company and what's good for the university? And I think there are more examples of that, but I think there's a lot more needed, particularly to have that expertise within the university from the education side that will allow a synergy between what's good for industry and what's good for the university.
Really interesting. Just a quick note, Professor Jonathan Seville, who's chair of my education committee, so I have to say this, otherwise he'll tell me off, mentions that the Engineering Council has an inquiry into the practice of accreditation right now. So please do look on the Engineering Council website to engage with that, and that should help some of the issues discussed here. The conclusion you showed at the end was really interesting, and one of the questions is, is there a roadmap to addressing the direction in that conclusion? Is there a kind of a useful template that people can follow to help get to those outcomes?
And there is. I mean, I actually conducted some work, co-sponsored actually by the Royal Academy and MIT a few years ago, looking at that process of change. What are the steps that institutions need to go through? Actually, more recently, I've conducted a piece of work looking at the roadmaps for institutions changing their rewards systems. Of the universities that have tried to make that change successfully and unsuccessfully, what are the key steps that they go through, and what are the challenges that they face? As I said before, I think a really key part of that is engaging early with things as well, like accreditation or any kind of institutional requirements or union requirements. That actually these things often only happen once a year, and you need to engage early with that. But I think really listening, the institutions that have really listened over a period of a number of years to the needs of industry, the needs of their students, and the priorities of their academics are the ones that have really been successful. And I think also had a flexibility about what, not everything is going to work. And the sense that the curriculum that you launch on day one won't necessarily be the curriculum that works long term. And I think that flexibility from leadership that says that there's a more agile approach here to the design and delivery of this, and that there will be things that won't work, there will be new opportunities that come on. And I think the other part actually is also not saying, hey, we've designed the curriculum, let's hang up our boots and focus back to what we were doing before, but actually having this sense of continuous development. And that's something that's very strong at Olin College, that you really do rip up a curriculum every few years and rethink what it is, so to really to keep it fresh, that this is something that's constantly changing. Yeah. And I think that's a very difficult thing to do. The other piece actually is about measuring impact. The key challenge, I think, that many universities face is they make a very positive change. They get a new department head, a new dean, a new vice chancellor who says, what's this new curriculum that's taking up more resource than it might? How can you justify this? And actually, if at that point there isn't data that says, look, our students are learning better, whatever it is, our graduates have different opportunities, that actually a lot of these changes can very quickly be stifled and return to the status quo quite quickly. So I think having the data that says this is having, if it is indeed having, but what impact this is having, and not being too reliant on a small group of people to deliver that, so that it really is embedded across the curriculum as a whole.
Right. Someone called Peter Goodhue, never heard of him, says, are you aware of any efforts to get students to make things without actually being in attendance at a university? He says, he says that he heard you say that you're about to study this, but he said the need is great. We can't wait. We need an immediate answer. We can do pretty much everything else online, albeit not as well as face-to-face, but making stuff is more difficult. Now, I have heard of some universities thinking about posting out little lab kits and things like that to students. One university in particular was appalled at the state of soldering skills for their students, so looking at sending out soldering irons and things like that. But do you know of any other kind of practices, any other organizations looking at this quickly?
Yes, I mean, I think all institutions are looking at this. How do we do? And there are, remote labs that people can access, but absolutely, a lab in a box being posted out. What's in that? What are we asking the students to do? And how can we support that? But also, what can students do within their own homes? Going almost through the recycling bin and seeing, okay, so what common pieces are going to be within each student's houses, and thinking about different types of design solutions that are low tech, but I think a lot of institutions are delivering stopgaps at the moment with a view to developing something a little bit more coherent. And I hope I'll have, well, I'm starting this project next week. So, as soon as we start to have, and what we're doing actually is we're developing a website. So as those examples come up, we'll be putting them on a website, and I can certainly share that with you so that people are able to access that. It'll all be open source, so people will be able to access that and learn a little bit more about what people are doing.
Thank you. Sorry, I'm also trying to look at the questions and pick up some of these interesting questions. The new blank slate universities, you mentioned that some of them are going for 50-50 gender split and things like that. How are they able to do that? And can these emerging universities, the approaches they're taking, can they be applied to other engineering institutions as well, because of course we do have particular challenge in this country with diversity, not just gender, but across all characteristics.
Yes, I think for many of those institutions, it is easier when you're starting a new institution to have as you say, to have a completely blank slate and really target the students that you want to attract. But I think for a lot of these programs that are focusing on challenges and addressing particularly global and societal challenges, do attract a different demographic of student intake. But I think people are doing interesting things in the civil engineering department at UCL as a preempt before the engineering education program was released. They actually said, we no longer are asking for maths and physics A-level. We just want you to get high quality A-levels. And I think those kind of things, sending out signals that we're looking for a broader cohort of students, do make a difference. And I think when students come and see and are part of induction day, so at Olin College, they actually have induction weekends where students come and do some of this hands-on work and are part of teams, that I think they can get a better sense of what is engineering, what is this all about, rather than something that's much more abstract. So I think a lot of those things are helping to broaden the appeal and of those programs. But I think there's an awful lot of hard work as well that goes into that, and engaging with schools and engaging with a wider community to bring those larger groups in. And I know from some of the previous research that once you reach maybe 35%, you reach a critical mass where actually you don't need to be constantly attracting the cohort of female prospective students, because from that point onwards it's self-sustaining. Because and the word is out that this is the place to go to. So but I think there's an awful lot of hard work that goes in there as well.
We're rapidly running out of time, but I do want to ask one very final question, which is posted much earlier. Now, there are many people engaged and interested in transformation of engineering education. How do we get the message out there? How do we disseminate this to the leaders? Because very often you'll find it's interested academics who have a more thoughtful approach to teaching and learning. You might see the same kind of people attending the same conferences, whether it's CEFI or WEEF and things like that. How do we get this kind of discussion happening with deans, with heads of departments, with pro-vice chancellors and faculty as well?
I mean, I think when I was talking about the drivers for change, I think that competition piece is a big one, actually, that, you know, some of these institutions are teaching very differently, are attracting a broader cohort of students, that actually there's a competition there, that the status quo is no longer necessarily the safe place to be. And I think that really does prick up people's ears when you hear that MIT, for example, is fundamentally changing its education. That does have an impact. Something that I've noticed as well, which I think is really interesting, is a lot of the deans and the heads of universities that are making these changes. When you have a conversation with them, it strikes me how often they actually say, do you know, I've been a passionate teacher and I've been wanting to make a change for all my career. Now I'm in a position to do so. I want to do it. So I think there's also a sense that there's a sort of cohort, a generation of academics that are coming through with very different ideas who haven't really been able to realize them. So I think between those two groups, there are, I think, a lot of changing attitudes, but I do think, look, you know, if you look at the global rankings for engineering, which really are largely built on research performance, you know, more and more of those institutions in the top 20 are not just incrementally changing, but quite radically changing their engineering programs. I think that's the message that will probably have the biggest impact.
Thank you. Thank you again, Ruth. That's just for an excellent talk and a great Q&A session there. We'll hopefully be hearing from you again later in this webinar series when we look at the career progression framework that you've helped develop for universities. It's a really fascinating thing, a framework for looking at how we measure academics' contribution to teaching alongside research. That's it from us this week. Just a quick mention that Professor John Perkins will be providing a lecture for the Engineering Professor Council this Friday. You can register at bit.ly/EPC Perkins, and you can see the wonderful Professor John Perkins giving his presidential prize speech there. Next week, we are going back to school with the wonderful Dr. Lynn Bianchi from Manchester University. She's going to be talking about tinkering as a mechanism for learning, as a purposeful approach to engineering in primary schools. It's going to be a lot of fun and very useful as well, and very informative. What's the point of engineering when you're an 8-year-old? That's the question she's going to answer. Do join us again next week at 11 a.m. Until then, goodbye.